Today we're going to look at Newton's laws of motion. And so we're going to look at those three laws, what they mean, and how they interact. So the first law, object at rest remains at rest unless acted upon by a net outside force. So what this one is talking about is this is talking about a situation where I have a constant velocity. If my velocity is constant, my acceleration is 0. It also means that if I add up all the forces acting on it, I get 0. That's what we mean by the net force is 0. So the sum of the forces equals 0. The second law says, well, if you apply a force, a net force, it's going to change its motion in some way. So the second law talks about a changing motion or a changing velocity. So my acceleration is not equal to 0, and how I figure out what it is I add up the forces and find the net force, and that will equal the mass times the acceleration. Now in both of these laws, we are looking at the forces acting on the object, and that's important. Because that's what leads us to the difference between the first two laws and the third law, is this is the forces on the object. So, if you're going to look at the forces on an object, you're going to need a free body diagram. And we use FBD to talk about a free body diagram. A free body diagram will help you sum up those forces, and if it's equal to 0, we can solve the problem that way. If it's equal to MA, we can solve the problem that way. Now for the third law. The third law is a little bit different from the first two, but just as essential. This one is talking about opposite and equal forces between objects. Okay, so we have opposite and equal forces between objects. Now, object is a pretty wide range. It could be the earth, it could be you, it could be a particle. It can be just about anything. But notice the big difference here. The first two is talking about forces on an object. The third law is talking about forces between things. Okay? This between idea, because it's relating multiple objects, this is what we use to deal with multiple mass problems. And so this is where we get a common force for multiple mass or multiple object problems. Okay. Now, this is also the problem, or the law I should say, that gives students the biggest difficulty because it goes against a lot of your feelings. Okay? And I want to talk about those feelings because physics, we want to push those feelings down. We don't want those feelings involved. We want to use our brains, okay? So, third law. Take an example of a semi-truck driving down the interstate and a little fly. Buzz, pow! That semi-truck hits that little fly. Does the semi-truck change its velocity at all? Hardly at all. That fly gets creamed. Now, I ask you, which one had a larger force on it? And Newton's third law, using our brains, not our feelings, says they're opposite and equal. But you say that truck barely felt anything and that fly got just smattered. This is what we need to keep in mind. That your feelings are thinking, all right, that fly experienced a big acceleration, so it must have had a big force. And the truck had a small acceleration, so it must have had a small force. But there's that third term, mass, that's involved in the problem. It's a 3-variable situation. The fly and the truck have different masses. It's the reason they have different masses that they have different accelerations, because the force between them is the same. So again, we want to use our brains and these rules, these laws, to identify situations and figure them out. Don't go with your gut feeling.